Hey everyone, welcome back to Cloud Baba. Today we are going deep into something that's been on a lot of people's minds, that is Kubernetes. If you learn it with using EC2, you did nothing wrong. But here is the truth. Most modern production systems are no longer running the way you think. Companies didn't stop using servers, they changed how they manage them. In this video, I will explain what actually changed from EC2 to Kubernetes and why modern DevOps looks completely different. But let's start with how things used to work. The traditional setup looks like this. You launch EC2 instances, you install your application manually, or maybe you have some shell scripts. You attach the load balancer in front, configures auto scaling, and when something breaks, you step into the box and figure it out. This worked, and honestly, many companies still run this way. But problems started appearing at scale. So, configuration drift. What is that? This is where your server slowly diverges because everyone's making manual changes. Next would be slow deployment. Executors feel slightly risky event. Difficult rollbacks. When something goes wrong, there is noisy and low button. Next would be Snowflake servers. Every machine is unique, impossible to reproduce. And when you throw microservices into the mix, managing dozens of services across dozens of instances become a nightmare. Then came containers. Instead of configuring service manually, we started with packaging application with all of their dependencies together using Docker. Now get the same environment everywhere. Dev, staging, production. Along with that, faster deployments, full portability, predictable builds. But here is the thing. Running one container is easy. Just tuck around and you are done. But running 1,000 containers in production, that's a completely different game. You need automated scheduling which containers goes on. With Snow, you need horizontal scaling, speed out mode once traffic spikes. You need autos, you need self-healing, you start a container that crash, and you need service discovery so containers can find each other. Yeah, you need orchestration for this. So that's where Kubernetes changed the game. You no longer say start this server. You say I want 5 replicas of this application. And here you instead of managing servers, you start managing the desired state. So when you say I need 5 replicas of this application, Kubernetes say here goes nothing and starts them. It handles scheduling, scaling, self-healing, rolling update, and it will maintain the 5 replicas each time. So what is Kubernetes? Let me quickly break down the key building blocks. First one is the pods, the smallest deployable unit. So whatever we write the app or the program, it's the pods where we deploy. It's the one or more containers that share network. Next would be services, a stable network endpoint that load balances traffic across your pod, across your pods. Next would be deployments, manages the desired state and handles the rolling updates. So what is rolling updates? Again, the also state, saying desired state you mentioned, like you said 5, if we always keep the 5 Even if one is crashed, it will self-rebuild and again keep the file busy. Even while deployment, so if you are deploying a new version, it will keep the same file disaster until the new version is working and running fine without turning at the older one. Another one would be the namespace, that is a logical isolation for multi-team or multi-environment cluster. So this isn't just a technology change, it's a mindset shift. Old way manage servers manually, search and patch in production, and debug on the machine. New ways that declare infrastructure as code, will keep test workflows, automate everything, so CI/CD and adapt and observability first approach. The role itself evolved from system administrator to platform engineer to SRE, that is the site reliability engineer. What changed in DevOps? Let me put concretely four big shifts happened. First, infrastructure as code. That is the Terraform, Cloud Formation for the AWS will be the infrastructure lives in version control. Second would be immutable infrastructure. You don't page server, you replace them, pick your image, deploy fast. Third, CI/CD automation. Jenkins, GitHub Actions, Argo CD, let's say every commit can prepare a safe rollout. Fourth, observability first. Prometheus, Grafana, ELK, CloudWatch, instrument everything before you ship. At scale, production systems demand certain things: microservice, orchestration, zero downtime, deployments, auto recovery from failures, safe and progressive rollouts, reproducible environment. And EC2 was not wrong, it simply was not enough for hyperscale. That's why companies moved to Kubernetes. So, how the modern DevOps looks like. If you're starting today, here's the real position I would recommend. Start with EC2 fundamentals, understand servers, networking, storage. Step 2 would be understanding containers or Docker, learn to containerize applications. Step 3 would be Kubernetes, that is orchestrate at production scale. Not just some new apps to some real application or microservice. Step 4 would be CI/CD, automate your build and deploy pipeline. Step 5, everything through Git. Yep, Git should be the single source of truth using the GitOps, that is the Argo CD. Step 6 would be SRE and observability. Run systems like the data tellers. If something breaks, you have to pay the customer, right? So, final thought. Kubernetes is easy to teaches infrastructure. Kubernetes teaches production system. Cloud builds real-world engineers. Thanks for watching. If this video helped you understand the modern DevOps landscape, go ahead, go ahead and hit that like button, subscribe to Cloud Baba, and turn on notifications. I'm building a full series on real-world cloud and DevOps practice. Drop a comment below. What topics should I cover next? I read every single one. Until next time, this is Cloud Baba. Keep building.